Okay, word problems. So this is a graph that is describing temperature over a 4-hour period. Describe it and discuss the domain of this polynomial representing real life. Okay, so if this is describing temperature over a 4-hour period, would it make sense that this x-axis is representing what in real life? Time. And the y-axis is representing what in real life? Temperature. Okay. What do you know about time? Can't be negative. So, you know what? This part of the polynomial doesn't exist. And it would really start right there. The starting time 0. The temperature is negative 12 degrees. Okay, so if we start here, the temperature is negative 12. It warms up. So an hour later, the temperature is 0. Then it gets colder. Then it warms up, and then it gets colder. Okay? So this gets colder, 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 colder. Would it make sense in real life that eventually that just doesn't make any more sense? It's not going to be at negative 1,000 degrees out. Okay, so discussing the domain. So we obviously know with the domain that, right, x, 0 is the start, and then on this one I don't have a definite ending, but I know that it's not going to be infinity. So, right, that's kind of just an idea, just discussing it. Okay, we need to make an equation. Okay, so I'm going to go let y equal temp and let x equal hours. FYI on your test, be careful if I say use the letters H and T or whatever, you got to use H and T. I catch a lot of people not using the right letters. Okay. Y equals some kind of coefficient. Give me a factor that you would see as an x value. What's the first thing you see? Right here. What's the first x-intercept? 1. So x minus 1. What's physically happening right there? Bounce. Squared. Then it crosses again at 2, so x minus 2. And then x minus 3. Look at all your x's. You have 4 of them multiplying together. What do you already know about a because of the visual? It'll be a negative value. Okay, so what do we have to do? We have to figure out how to get a negative 12. How do you get a negative 12 when x equals 0? What does this all multiply to right in that section? Negative 1 squared. Negative 2 times negative 3. All of that multiplies to 6. So a is negative 2. Good, because we said to ourselves it's probably a negative value, right? So y equals negative 2 there's my equation. Okay, so you haven't really done anything new. We know how to do that. Okay, find the temperature after 4 hours. So what am I going to do? If I'm trying to get the temperature, but I know the time I'm looking for is 4 hours, what do you think I'm going to do with that 4? Trace 4, exactly. How do you do that in pre-calc? The method that I'm looking for starts with a P, the letter P. What do you do with 4? If you're thinking, what's the temperature at 4 hours? What are you going to do? Plug it in. Put the 4 into the X. Make X 4. So if I'm trying to get the temperature at 4 hours, you're making the X 4. Okay, and then that's just a math.
So where did this 4 come from?
The question says find the temperature after 4 hours. So
So you just
plug a 4 in. So really, it's way down here, right? 4, negative 36. So in this question, the graph is representing it over 4 hours. So really, we're ending this domain at 4 because it's saying we're going to stop here because it's not making sense after 4 hours. Estimate the max temperature. So visually, where would you just put a dot where the temperature looks like it's the highest? Visually, where would you put a dot? I would say right there-ish. This is going to be an estimate, so it doesn't have to be exact. So sometimes I give you a graph and I would have a number there and you would just have to line up your finger and give me the number. I don't on this graph. So what kind of X value are you guessing it's at? 2.5. Yeah, it's just a guess. So if you're going to guess it's at 2.5 hours, what are you going to do to get the temperature at 2.5 hours? Plug it in. 2.5 minus 1 squared. 2.5 minus 2. 2.5 minus 3. Okay? Estimate. So my calculus people, next semester we're going to get that exact. Okay, that's it. Okay, then the last one is a cutting paper question. Okay, so it starts with a piece of paper, and what it's going to do is it's going to cut little squares out of the corner. And the squares that you cut out will all have the same dimension, which you don't know.
It's a loaf of bread. Oh. Oh, I can't draw that.
Okay, you need to be a visualizer here. So if I have a piece of paper, I started with a piece of paper and I'm cutting the same corner out of each. Okay, maybe you've done this. Have you ever made one of those like little boats and then you float it in the water? Okay, so if I cut corners out of a paper, what do? I fold all the sides up. And what does it make? A box, right? Okay. So that's what you do. So you cut the corners off, and then once you fold it up, it's a box shape, okay? Okay, so let's talk about the dimensions of this box. What is the height of this side once you fold it up? Whatever x is, yeah. You cut x away and you fold it up, that height is x. Okay, now what is this side of the box, which on the paper would be like this? This side on the flat paper is that. 6 minus 2x, right? Because it was 6, and you cut off an x, and you cut off an x. Same with the other side because it was the same. Volume. How do you do volume of a box? Length, width, height, right? Length times the width times the height. There we go. That's it. Write an equation. Done. Model it with a graph. Okay, what is the x-intercept of this bracket? What would cause that to be 0 if x was a pick 3? This is the same, right? You could have also written this, right? Either one. So 3. What's going to happen at 3 then? There's going to be a bounce. And what's the x-intercept of that bracket? X would have to be 0. Okay, so there we go. We did a graph. Discuss the domain is the next question. So if this is the volume, this is not all going to work. Okay? X is a portion that I'm cutting off. What do you know about how much you can cut off? Can you cut off negative? No. So guess what's not going to work? That's not going to work. You can't cut off negative. You can't have negative volume. And this part of the graph is not going to work. Why is it not going to work? So pretend x was 4. What happens if x was 4? Can you cut off 4 and 4 on a 6-sided paper? No, it's too much. There's not enough there. Okay? Also, what about 3? Can you cut off 3 and 3 on your paper? No. If you cut off 3 and 3, what's the length of your side? 0. Can you have a box with a length of 0? No. And You can't be on that as well. So what is your domain? 0 to 3 round brackets. You can't be on them because you can't cut off the whole side and you can't not cut off any, right? And the last question, estimate the max volume. So where would you put the max volume? Whatever you're estimating. So what kind of x value do you want to try? 1.5? I'm just going to kind of go in the middle of it. Okay, so what am I going to do if I'm going to use an x value of 1.5? Plug it in. Okay, so it's an estimate. It's not actually going to be the exact. Okay, anybody have an answer for me? Because I didn't do it. Anybody have a number?
13.5.
13.5 centimeters cubed. Okay, look at me. I'm doing the exact. If you want to know the exact, here's what I would have done. Second, calculate the max. It's between 0 and 3. And 16 was actually the highest volume it would have got to. But. Okay, but you don't know how to do that. So it's an estimate. Good enough. Okay, that's all I'm looking for is an estimate.